Hello everyone, this is a short tutorial on how to use the geomaps and geocoordinate generating functions within the Heatmapper interface. Heatmapper is a free online application that visualizes different types of data as heat maps. It's the first tool of its kind that allows users to display many different classes of heat maps in one user-friendly web application. Heatmapper has 5 different classes of heat maps: expressions heat maps, pairwise comparison heat maps, image overlay heat maps, geomaps, and geocoordinate heat maps. This tutorial will only cover the geomap and geocoordinate functions of the Heatmapper interface. Geomap heat maps display heat maps based on country, state, province, and other political boundaries. You could use this Heatmapper to display environmental indicator data for different provinces in Canada or even different countries across the world. Or you can use it to display the prevalence of a disease or its effects around the world and many other such applications. Geocoordinate heat maps, on the other hand, display data on geospatial coordinates like latitude and longitude. This heat mapper could be used to visualize animal population densities across a region or deaths from a certain disease over a period of time. Let's navigate to the Heatmapper interface. Open up your favorite browser and type in heatmapper.ca. This will take you to the Heatmapper interface. All of the heatmappers are listed here. The geomaps function takes in comma-separated values, tab-delimited files, or Microsoft Excel data. The data here must contain at least 2 columns with region names in the first column and the numeric values for the input in the second. The geocoordinate function takes in the same type of files. The data here must contain at least 2 columns with region names in the first column and the numeric values for the input in the second. An optional third column containing values can be included for calculating weighted density estimations instead of basing the estimation on density of points. At least one value must be strictly greater than 0 if the value column is used. The first row must contain the names for each column. Let's go through the Geomap Heatmapper first. The tab on the top of the page shows the 5 classes of Heatmapper and can be used to navigate between them. Let's take a look at the options in the Geomap Heatmapper through an example file. This input file has environmental indicator data in it. We can use this file to generate a Geomap heatmap. The map that's created is interactive. Hovering over an area with your mouse will show the value for that specific region. The range of interest option can be used to adjust the color assignment cutoff values. This can be used to group together or better differentiate certain value ranges. The column to use option allows the user to select the column from the input file to display. There is also the option to show or hide layers. This allows the user to add or remove heat map layers and to display or remove certain features of the map. Deleting the Contour Lines tab, for example, will remove the region outlines on the map. This option may be a useful visual aid for viewing the overall map pattern. The rest of the options allow the user to select the color scheme and intensity of the plot. The plot can then be downloaded. There's also the option to further refine the plot and provide a legend title through the Advanced Options link. Now let's take a look at the geocoordinate heat map. The header bar can be used to switch over to the geocoordinate interface. Let's review the options available here through an example file. This interface also includes a show or hide layers option in order to add or remove heat map layers from the image. This interface also includes a map type option. Through this option, the user can change the format of the map displayed. The 3 options besides default are positron, toner, and watercolor. The positron view is a grayscale mapping style. The toner view is a black and white mapping style. This may be useful for clearly identifying jurisdictional areas or borders. The watercolor view is a mapping style that uses a watercolor palette to differentiate features on the map. The Gaussian radius multiplier option allows the user to adjust the bandwidth for kernel density estimation. This may be useful to more clearly define areas of differing intensities and transitions. The contour smoothness option allows the user to adjust the number of grid points in each direction for kernel density estimation. Lowering the value limits the number of points that form the contour lines on the map. This results in a more rugged outline. The rest of the options allow the user to further refine the color and opacity of the image before downloading it just as in the GeoMap interface. Thank you for watching.